Eggs. Simple, everyday, humble, yet filled with mysteries you've probably never heard before. From ancient history to jaw-dropping science, today on Fact Quest, we're cracking open 10 little-known facts about eggs. And number 7 will completely change the way you look at breakfast. Long before the first chicken was ever domesticated, our ancient ancestors were intrepid foragers. They would brave treacherous climbs and watchful predators for a precious high-energy prize, the eggs of wild birds. This was a risky but vital source of nutrition, a compact package of life-giving protein that fueled early human development. For these hunter-gatherers, finding a nest was like discovering treasure, a moment of triumph that promised a rich and satisfying meal. Our relationship with eggs transformed around 6,000 years ago in the jungles of Southeast Asia. Here, humans began domesticating the wild jungle fowl, but surprisingly, it wasn't for their meat. The primary motivation was their incredible ability to produce a consistent, renewable food source. Chickens were valued as prolific egg layers, a living pantry that provided sustenance without sacrificing the animal itself. This revolutionary idea spread along ancient trade routes, and soon, the humble chicken and its precious eggs had conquered the globe, becoming a staple for civilizations from Rome to China. As chickens became a fixture in human settlements, their eggs took on deep cultural and symbolic meaning. In ancient Egypt and Persia, the egg was a powerful symbol of rebirth, fertility, and the promise of new life. They were decorated, offered to the gods, and became central to springtime festivals celebrating renewal, a tradition that echoes in our own celebrations today. But not all eggs were the plain white or brown we might imagine. Thanks to thousands of years of selective breeding, the eggs we see today come in a breathtaking artist's palette of colors. Depending on the breed of hen, you can find eggs that are pristine white, rich chocolate brown, pastel blue, earthy green, and even a delicate pinkish cream. A white leghorn, for instance, will lay a classic white egg. A French Maran's is famous for its deep chocolate brown eggs. The quirky Araucana chicken from South America lays stunning blue eggs, while an olive egger, a crossbreed, produces beautiful shades of green. The color is a signature of the hen's genetic makeup. So, how does an egg get its color? It's a fascinating biological process that happens during the final stages of the egg's 26-hour journey through the hen's oviduct. The shell is naturally white, made of calcium carbonate. The color is essentially painted on by pigments. A pigment called protoporphyrin is responsible for brown shades, and it's deposited late in the process, coating only the outside of the shell. That's why a brown egg is white on the inside. But for blue eggs, a different pigment called eucyanin is used. It's deposited much earlier, seeping through the entire shell. If you crack a blue egg, you'll find it's blue on the inside too. Speckles and spots are formed when the egg rotates or pauses as the pigment is applied. And here's a common question. Does the shell color affect the egg's taste or nutritional value? The answer is a definitive no. The color is purely cosmetic. The flavor and nutritional content are determined by the hen's diet and freshness, not the color of her feathers or the shell she produces. A blue egg and a brown egg from hens on the same diet are identical on the inside. The largest eggs ever found came from the elephant bird of Madagascar. This colossal, flightless bird, standing nearly 10 feet tall, roamed the island until its extinction around 1,000 years ago. It laid eggs of truly epic proportions, over 13 inches long and weighing a staggering 22 pounds. To put that into perspective, a single elephant bird egg had the same volume as about 150 chicken eggs. Imagine the omelette that would make. These fossilized giants give us a direct link to a lost world. But what about the most famous prehistoric parents, the dinosaurs? While some dinosaurs laid enormous eggs, none matched the sheer volume of the elephant birds. Sauropods, the long-necked giants, laid spherical eggs about the size of a cantaloupe. Finding nests of these fossilized eggs has taught paleontologists incredible details about dinosaur behavior, revealing that many were caring parents. But it's not just size that makes an egg remarkable. It's the perfection of its design. An egg's shape is a masterpiece of natural engineering, making it incredibly strong. The secret lies in its curves. Much like the arches in an ancient Roman aqueduct, the curved shell distributes pressure evenly across its entire surface. This means it can withstand a surprising amount of uniform force, protecting the delicate life growing inside. The shell itself is a marvel. Composed almost entirely of calcium carbonate, it's dotted with thousands of tiny pores. These pores are crucial, allowing oxygen to enter and carbon dioxide to exit, essentially letting the embryo breathe. Yet, despite this incredible strength, the shell has a built-in weakness. When you tap an egg on a sharp edge, you concentrate all the force onto a single tiny point, fracturing the crystalline structure. This is the same principle a chick uses to escape. It develops a tiny sharp horn on its beak called an egg tooth, which it uses to pip the shell, creating the first crack in its journey to the outside world. Finding two yolks inside one egg might feel like winning the breakfast lottery, but some hens, especially young ones, lay double yolk eggs more often than you'd expect. Want to know if your eggs are fresh? Place them in a bowl of water. Fresh eggs sink. Older ones float because the air pocket inside grows over time. A yolk's color is a direct clue to the hen's diet. A deeper, richer color often indicates more nutrients. This vibrant golden yolk means the hen has been feasting on a natural diet of grass, seeds, and insects. While we mostly think of chickens, reptiles, fish, and even mammals like the platypus also lay eggs, each uniquely adapted for survival. In medieval Europe, eggs were so valuable they were sometimes used as rent payments or traded like coins. But the journey from a raw egg to a perfect hard-boiled one is a masterclass in kitchen chemistry. It all comes down to precise timing and temperature control. Inside the shell, you have two main components, the albumin, or egg white, and the yolk. When you introduce heat, the proteins in both begin to unfold and tangle up in a process called denaturation and coagulation. The egg white, which is about 90% water and 10% protein, starts to set first, at around 144 degrees Fahrenheit. The yolk, richer in fats and different proteins, needs a slightly higher temperature, beginning to thicken around 158 degrees. This is why you can achieve a firm white with a jammy or even liquid yolk. But if you keep the heat on for too long, you risk that dreaded greenish-gray ring. This is a harmless but unappealing chemical reaction between the sulfur in the egg white and the iron in the yolk, forming ferrous sulfide. It's a sign of overcooking, but it's perfectly safe to eat. The secret to preventing it? Don't overboil, and cool the eggs down quickly in an ice bath. This rapid cooling not only halts the cooking process, preventing the green ring, but it also causes the egg white to contract, pulling away from the shell's membrane and making it miraculously easier to peel. This control over proteins is what makes the egg one of the most versatile ingredients in the world. Beyond boiling, think about what eggs can do. The yolk contains a powerful emulsifier called lecithin. This molecule has a unique structure that allows it to bind oil and water together, two things that famously don't mix. Without egg yolks, you wouldn't have creamy mayonnaise or rich hollandaise sauce. Then there are the whites. When you whip them, you're physically denaturing their proteins, forcing them to unfold and trap air. This creates a stable foam that can be baked into light, airy meringues or folded into batters to make soufflés rise. From binding meatballs together to giving a golden sheen to pastries, the humble egg is a true culinary superhero. So, from the ancient symbolism of rebirth and the incredible biology of its formation to the complex science that unfolds in our own kitchens, the egg is so much more than just a simple food. It's a package of life, a historical artifact, and a cornerstone of global cuisine. We've journeyed through its history, cracked open its science, and marveled at its versatility. Which fact on our journey surprised you the most? Was it the double-yolked wonders, the ancient traditions, or the chemistry of a perfect boil? Let us know in the comments below. And if you found this exploration as fascinating as we did, crack that like button and subscribe for more mind-blowing facts every week right here on FactQuest.